So we're going to calculate the following antiderivative using the method of partial fractions. So the first thing we want to do is factor the denominators completely as possible. So x minus 2 over x squared times x squared plus 1 dx. So we need to set up what this is going to look like. And we have what's called a repeated linear factor because this is the factor of x being repeated twice. So we need to represent all its iterations. So when we go to write this up, we're going to have a over x because that's one of our linear factors. But we have to represent all its powers, so we're going to put a b over x squared. If that had been an x to the fourth, we'd have a c over x cubed and a d over x to the fourth. So however many are repeated have to have a representation here. The next one's an interesting one because it's x squared plus 1. It's what we call an irreducible quadratic factor. Quadratic because of the second degree, can't be factored anymore. So it's possible that its numerator could be linear, so we have to represent that. So we're going to put cx plus d over this one, over x squared plus 1 dx. Now what I like to do next is just deal with the numerators, but I figure out what the numerators look like by looking at the denominators. This is my least common denominator. So what would I need to multiply this term so it has this as a denominator? Well, it only has one x. So a would have to get multiplied by an x to give it the x squared, and also by x squared plus 1 to give it this term here. And right now what I'm writing out over here is just the numerator. I'm not worrying about the denominators because I can set up my system from here. I do the same thing with b. It's already got the x squared. It just needs the x squared plus 1. So b times x squared plus 1. And then finally, you do have to do cx plus d, and I recommend putting it in parentheses to keep track. It already has the x squared plus 1. It just needs the x squared. Now this is the numerator if we were to add these fractions together with a common denominator. So it should come out to be our old numerator of x minus 2. So we're going to multiply this all out and see if we can create a system of equations. So distributing this, we get ax cubed plus ax. Distributing the b, we get plus bx squared plus b, and multiplying this guy out, we get plus cx cubed right here, and plus dx squared equals x minus 2. Now what I've always liked to do to create my system is I like grouping the coefficients of the x's. And so I have x to the third that has coefficients. I've got an x squared, I've got an x to the first, and I've got an x to the 0. And this will make 4 equations, which is good because we have 4 variables, a, b, c, and d. So here's all the terms with x cubed, right there and right there. So a positive a and a positive c, so a plus c. And notice there's no x cubed term over here, so a plus c must equal 0. So that's going to be one of our equations. Now for x squared, we have 1 here and 1 here. So that tells us that b plus d must also equal 0 because there's no x squared term over here. We only have one x to the first term, and that's a. And notice that the x to the first term just has a coefficient of 1, is just not written there. So we already know a equals 1. And then our constant term is b. Well, b has to be negative 2 in order for this to all be true. So we already know a and b, and notice if we solve these, this tells us a equals negative c and b equals negative d. So c is just the opposite sign of a, and d is just the opposite sign of b. So we have enough to put this together. So let's see what this will look like, and then we'll see how we're going to compute our integral from here. So a is 1, so we have 1 over x. B is negative 2, so minus 2 over x squared. And then c is a negative 1. I'm going to keep the negative 1 up here for right now. So negative x plus 2 over x squared plus 1 dx. So there is our integral. Now I'm going to make a couple modifications before I go and solve this thing. Number one, well, this is just going to be a natural log, but I'm not going to do an antiderivative yet. I'm going to keep it as 1 over x. This one I'm going to rewrite because this is not a natural log. We fall into that habit very quickly. So minus 2x to the negative 2, it's going to be a power rule. This one here, because it's not a U-substitution as written, it would give us issues. I'm going to split it into two integrals, both over x squared plus 1. So one of them is going to be plus negative x over x squared plus 1. And then the other one will be plus 2 over x squared plus 1 dx. So hopefully you can see that these already have a common denominator. We just add them back together to get this guy. They're going to be easier to solve split up. So this guy here is the only one that's going to take a little extra work because it's going to be a U-substitution. But let's see what we have right now. Let's actually start doing the antiderivative. So the antiderivative of 1 over x, as we mentioned earlier, is natural log of the absolute value of x. The antiderivative of negative 2 times x to the negative 2, this becomes x, increase the power by 1, divide by your new exponent. We'll fix that up here in a second. This one I'm going to save here in just a sec. Now this one, so we still have, well, let's change the order. We're going to write this one next. This is basically 2, well, let's write it this way. So plus 2 times the integral of 1 over x squared plus 1 dx, so that's this one, minus, that's the negative there, x over x squared plus 1 dx. Let's clean some of these up and finish them off. So this is just a natural log of the absolute value of x. Negative 2 divided by negative 1 becomes a positive 2. And if we want, we can write that as over x. This is the derivative of arctan. So we have plus 2 arctan of x. And then this one we're going to solve with U-substitution. So over here we're going to let u equal that denominator, x squared plus 1. And then du is 2x dx. So I'm going to need to add a 2 in here to get my 2x dx, which means I'm going to put a 1/2 out here. So this becomes minus 1/2 the integral. U goes on bottom, so it's just going to be du over u. And now we'll go ahead and solve that in the next line. So equals ln of the absolute value of x plus 2 over x plus 2 arctan of x minus 1/2. The antiderivative of du over u is natural log of u, so natural log. But remember, u is x squared plus 1, so I'm just going to sub back in the same step, plus c, and I don't need the absolute value because x squared plus 1 is going to be positive. Should say natural log right there. So there is our antiderivative. If you want, you can combine these logs because we're going to have a difference of 2 logs, but I'm not going to worry about that for this video.